All right, let's begin. Hello, everyone, and welcome to this QuickStart training session on what's new in SQL Server 2019. We are here with Abdullah Naseer, who is an expert on all things SQL Server. He's a Microsoft certified instructor, one of the youngest, at least that I know, if not in the world. And he'll be teaching some SQL Server 2019 classes very soon. He has done a lot of research and a lot of prep uh, for this webinar. I hope that all of you, well, if not all, then at least most of you saw the video that I made with my mobile of this session beforehand. And well, I don't want to hold this thing up any longer. So Abdullah, over to you. Let's begin.
Thank you so much, Itasham. Um, Welcome everyone to the training session. What's new in SQL Server 2019? You might remember me from the advertisement that we had for this training session. I know I don't look very different, especially with the hair situation. All right, so let's get started with the training session. First, let me quickly go ahead and introduce myself. My name is Abdullah Naseer. I work as an IT instructor at QuickStart, and I've been working with them for about 2 years or so. Um, like Itasham said, I'm a Microsoft certified trainer, MCSA and SQL Server development. That's my email address in case you have any questions for me. Right now, I'm in Karachi, Pakistan. Would you believe that? And that means I'm exactly 12 hours away from the Pacific time zone. So if you're connecting in from the Pacific time zone right now, it's really easy for me to do time conversions. I just convert AM from PM, and I'm in Pacific time zone. So right now it's actually 11 in the night where I'm at. And that I'm fine with that. So let's just get started with the class. That's enough about my introductions. Uh, yeah, so let's just get right into it. The course objectives. What are we covering in this course, right? So what are we talking about? At the end of this course, what should you expect to learn? So at the end of this course, you should be able to be familiar with, you should be familiarized with the new SQL Server 2019 big data clusters. That's a huge thing in SQL Server that's happening. It's a game changer for SQL Server. The SQL Server that you once knew is no longer that innocent little SQL Server that used to query your MDF and MDF file. It's no longer that. It's much more versatile. We'll talk about it. So there's this concept of data virtualization with the use of Polybase and big data clusters. So we'll talk about that. So that's one of the things that at the end of the course you should be familiar with. And you will also be informed about the changes that you should expect in the new SQL Server 2019 database engine, all the enhancements that have been made. Now so the thing about the database enhancements, the database engine enhancements is that there are a lot of different here and there kind of situation, some features here, some features there, because the database engine is not just an engine. It consists of many, many, many features. So I can't really summarize all those features in just a course objective. So we will look into this much in detail in the following lessons. And also at the end of this course, you will also be familiar with the fact that now you can run SQL Server on Linux. Now that's not something new to SQL Server 2019. That was new in SQL 2017, which was again introduced a while back, and it was actually introduced as it was actually kind of rushed. Microsoft kind of rushed it through because the competitors of Microsoft, they were having the ability to run SQL on Linux, and Microsoft wanted to be competitive, so they released SQL 2017 out of hesitation, I'd say. But SQL 2019 is not like that. It's a complete new version. Is expecting everything to be changed, expect everything to be different from now on. So we'll talk about what's new in SQL Linux in SQL 2019. So from 2017, what are the new things in SQL Linux? There will be some demonstrations that we will do in the lab environment, so do expect that. All right, so let's move on with the agenda. So now that's our objective. How are we going to go ahead and talk about this? How have we modularized the topics? So we have modularized this into 4 lessons. First, we're just going to talk about an overview of SQL Server 2019, looking at each and individual things, basically getting getting to the shallows, right? So you're on the shore and you're kind of getting to the shallows, getting to know it better. So the first module is just to know it better. The second lesson is really when it gets started. The huge difference from SQL 2017 to SQL 2019 is the big data clusters. Game changer for databases, game changer for SQL Server. So we'll talk about that in lesson number 2. And in lesson number 3, we'll talk about the database engine. Again, repeating myself, I can't talk much about it right now since there are a lot of features in the database engine. I'll just talk about it when we get there. There will be a demonstration on the database engine about one of the features that are available. And lesson 4, security, availability, and platform. So what's new in security, what's new in availability, and what's new in the SQL Server platforms. Now, keep in mind that SQL Server 2019 is yet to be released. It's in preview right now. You can download it, but it's a preview version. It's not an enterprise level version. So it's still, they haven't really said any release date as to when they plan on releasing it, hopefully by June or July. But right now, it's at this state, and let's talk about it. So we're going to talk about the changes that have happened till the Community Technology Preview 2.4. So that's the latest, and 2.5 just came about right now. So we'll be talking about 2.4. Right. So let's get started with the first lesson. So talking about SQL Server 2019 as an overview, what are we expecting here? So with the SQL Server 2019, the biggest thing that is happening is now you have intelligence over any data. When I say any data, basically what Microsoft did here is that they brought in a new kind of concept for SQL Server, that they wanted a software, a platform where you have your structured and unstructured data all in a single kind of box. So what you're basically will be doing now is that you have your T-SQL skills, and then you can also integrate your Apache Spark skills or your Spark actions and jobs, and use those 2 skills combined together to have an integrated environment for your structured and your unstructured data. So what do I mean by intelligence over any data? I guess we'll talk about that. This is just an overview. So based on that integration, based on the fact that SQL 2019 has this new concept of intelligence over any data, what we mean by that is the fact that you can have structured and unstructured data all in a single place, so that once it's all in a single location, you can apply intelligence, or let's say your machine learning AI or your own intelligence over that data in a single kind of platform. So we have really amazing things to talk about. We'll see how SQL Server 2019 has achieved that. So in SQL 2019, Linux is a platform, and so is Kubernetes. So in fact, SQL Server 2019 Big Data Clusters actually runs on Kubernetes. So we'll talk about that as well. Enhancements to Database Engine, again, we'll talk about this. AI capabilities, yeah, so this is something that we can talk about. AI capabilities are now, you can write, so previously you could use R, but now you can also use Python over any data. So let's say you have a storage pool of HDFS, a HDFS connected to a storage pool, and you have your HDFS nodes inside that storage pool. So now what you can do is with your SQL Server, you can query the HDFS system using your T-SQL language, or you can just create an AI using R or Python and run that AI, make it do some machine learning on that data that is in HDFS or in any other database, honestly, in Oracle or Terra database or MongoDB or Cosmo, or even if it's Internet of Things, even if it's big data. You can use these two languages to create those AI capabilities. All right, so let's get into the depths of big data clusters. So what is it? What do I expect out of it? How do I imagine that? So big data clusters is basically an entire concept. It all starts from the fact that we want, so the world, the trend, the business trends nowadays in BI is basically moving towards data virtualization. We no longer want to do ETL processes. We're tired of doing ETL processes from a data warehouse, moving it from here, copying it from here, shifting it there, kind of like a situation. We don't want that anymore. And nowadays, businesses are like, oh, we're done. And now the market trend is more towards data virtualization. So everyone prefers that. So what is data virtualization? What do I mean by that? Because we are very familiar with the data warehouse concept, us DBAs and developers, data warehouse was the thing, was how we used to do our analysis, was how we used to do our reporting. It was a central location to do data centralization, all those kinds of concepts in that data warehouse. But now all that is going to go away, and is going to go away and being replaced with data virtualization using big data clusters. So what I mean by data virtualization is basically the aspect that you are integrating your relational data, your NoSQL data, let's say your non-relational data, you can call it NoSQL data. So NoSQL is another database. Your HDFS data, so any kind of your structured or unstructured data, all in a single service platform. So that's what I mean by data virtualization. And there will be no moving of data. So when I say that you are integrating NoSQL data and HDFS data, I'm not saying that you are actually downloading that data into a SQL Server, because the SQL Server cannot handle big data, right? At least that's the old SQL Server. So that's not what we are doing. We're just virtualizing it. And how it works is based on this new technology called Polybase. Now, Polybase is not new. It's been there since SQL 2016, but now they kind of repurposed it into, well, I guess it's not really repurposing, but they kind of expanded the range for Polybase. So what Polybase can do, so how can Polybase help us achieve this data virtualization that will help us eliminate the need to do data copy from one place to the other and moving of the data and all that? So how is Polybase helping us with data virtualization? Well, what it's doing is basically it's creating external tables in your SQL Server. So you have your typical SQL Server, and what you do in your SQL Server is that you create something called as an external table. The external table is created by the Polybase engine, and when it's created, the external table, what it does is that it virtualizes your query on different platforms, such as MongoDB, Oracle, Teradata, uh, NoSQL, HDFS file systems, any of those kinds of systems where you store or manage RDBMS or DBMS, any kinds of databases. So that's what an external table does. It virtualizes your query against those databases. All right. So because of this Polybase technology integrated with the big data cluster, so Polybase is just one aspect of big data cluster. It's one of the driving tools of big data cluster because it is the reason why we can connect to different data sources and have that structured, unstructured kind of situation all in one box is because of Polybase. But also not just that, we are also bringing into this mix Kubernetes. I'll talk more about that in a bit. So with your big data clusters, you can also create data lakes that can easily be queried using T-SQL. What's a data lake? A data lake can be your HDFS file systems, your HDFS nodes where you're kind of storing all your big data or your unstructured data. So that's basically a data lake. And we usually used to get data from there or get insights from there using Apache Spark or any kind of Spark language. Now, you not only have that option, so now you can do that. Now, SQL Server comes with Spark, right? Since it comes with Spark, you automatically have the ability to get to big data and get query big data. So that's what Spark was initially meant to do, to get data from big data sources. But not only that, so that's one thing that the new SQL Server can do, use Apache Spark to get information out of your HDFS. But not only that, you can also use T-SQL to do that. So your normal T-SQL skills can also be used against your HDFS big data. Think how amazing that is. So this is completely a game changer. We never thought this would be the case. What I mean by that is, so the database engine, as far as we know, the database engine is just used to your MDF file and your LDF file. The database engine just reads from those two files, the data files of SQL Server. That has been the case ever since SQL Server was released, right? We just read the log files, the MDF files, and the LDF files. That's no longer the case now, though. The database engine is now, it now has the capability to read outside of those files, read from HDFS files, read from Oracle data files, read from many different locations. So that's really interesting, and all because of the concept of external tables. So we will expand more upon what else does big data have, because querying an HDFS just using a T-SQL language from a single computer is not going to be optimal, because HDFS has, again, a lot of data. And using just a single compute is not going to help you. It'll be very slow. So with data, so let's talk about how big data clusters is actually working around that. How is it making our queries faster against big data? Because T-SQL is not an engine that was used to handle big data. So how is this engine that's not really used to handle big data, how is it handling right now? So let's talk about that. So how does it work internally? Okay, so there's a lot of verbiage on this slide, I know. All right, so it all starts with Kubernetes. So your SQL Server, so the concept of big data cluster was only possible because of Kubernetes and how Kubernetes works with persistent data, containers, Dockers, nodes, and pods. All that kind of concepts of Kubernetes come into play come really in handy for the big data clusters, because the big data cluster uses Kubernetes as as an infrastructure as well as a platform. So it runs on Kubernetes, the big data cluster. So what you start off with first is just a Kubernetes system. And you have your SQL Server, let's say, existing outside the Kubernetes environment. So let's say the SQL Server is somewhere nearby, but outside the Kubernetes environment. What you can do in Kubernetes is that you can create a storage pool. The storage pool in Kubernetes that you create, by the way, Kubernetes has this concept of persistent memory that also that SQL Server also takes advantage of. I guess we'll talk about that later. So storage pools in Kubernetes, you can create those. And in those storage pools, the storage pools are basically made of multiple pods. Pods you can think of as containers in Kubernetes. So there's a node in Kubernetes, and inside nodes, there are multiple pods. Okay? So what you do in a storage pool is that you have many nodes and pods, and each node and pod can host a HDFS node. So HDFS has many nodes that it uses to scatter all the data across its file system. And it uses that structure, the redundancy structure that it has to kind of have the ability to store and have better, faster queries against big data. So you have your nodes and pods, and each node and pod can handle a single HDFS node. So if each and so I guess I should just draw this out. So think like this. Let's say this is the Kubernetes system. The Kubernetes system has a bunch of nodes and pods. So nodes are, let's say, these things, and inside them are pods. Or actually, I think it's the other way around. So what basically happens in big data cluster is that we create out of all of these resources. So these are our resources that the Kubernetes has to offer. These are kind of like isolations. So I can use this container or this node or this pod for any purpose that I want. I can install, let's say, Oracle on this one, Teradata on this one, some other database on this one, or some other application on this one. So I can do that. And it has this concept of replication and all that. So we have these resources from Kubernetes, and what we do is that we create this storage pool here. And in the storage pool, we have these pods, these nodes. And in these nodes, we have HDFS nodes that are storing HDFS data. And each node has Apache Spark and SQL Server capabilities. So Apache Spark, SQL Server, Apache Spark, SQL Server. So they have these kinds of storage pools. And inside those storage pools, you have your entire big data. So what you can do now as an application that is running SQL Server, so the SQL Server that you are running can be inside the Kubernetes system or outside, it doesn't matter. But basically, you have your, here, let's say, your SQL Server. What you can do now is that with any application, let's say an analysis application such as Power BI or reporting services or any kind of application that's using your SQL Server, or even a user, whoever is using. Now we can simply write T-SQL queries or HDFS or Spark queries and run them against this storage pool. So that's direct HDFS querying using either T-SQL or Spark. So a lot of companies have done this before. A lot of companies have been able to have systems where they have Spark language and SDFS because Spark is made for systems like HDFS. T-SQL was not. T-SQL was made for systems that are relational, systems that have relational databases, or I guess for the SQL Server. But now they have changed that, and now T-SQL can also be used for HDFS because how the query engine, how the database engine has learned to do that. So that's one enhancement. What you can also do, so this is the big data cluster. Now, directly accessing the storage pool through your SQL Server is not going to be optimal. Your queries will run very slow. So what you can do is that you can, in Kubernetes, you can create something called as a compute pool. So that's a compute pool, that's a storage pool. So in a compute pool, you can have multiple compute nodes. And each compute node can be used can be used against that storage pool. So basically, you can use this compute pool to really have that super fast queries against your SDFS. You can directly get to your storage pool, but going directly to your storage pool might be a bit slow. Using compute pools in Kubernetes would be faster. Not only that, so you can have compute pools and you can scale them out as much as you want. You can scale out the storage pool as much as you want. So there's a lot of scalability. You can also have another compute pool that might query your other systems, such as that are not HDFS related. Let's say there are Oracle DB or Teradata or things like those, Cosmo. So those things, basically, other things. So you can have another compute pool that's kind of accessing data outside of this system, outside of the Hadoop system. So all of this is kind of, so one more thing I'm forgetting here. You also have the ability, I guess I don't have any drawing space here. So you also have the ability to have data marts. Data marts are kind of what they do is they cache data. And when they cache data from, let's say, multiple sources, they cache data so that your big data runs faster. So imagine this, you have your HDFS data, and of course, this is also through a compute pool. You can't really you shouldn't directly get to your data mart. You should use a compute pool to use multiple compute nodes to get to it, to your data marts. So your data marts are basically caching of your big data. And when you cache your big data queries running against those data marts would be running in milliseconds. So imagine you're querying your big data in milliseconds. So that's a big game changer. You can even query your Internet of Things. So you can cache your Internet of Things data into your data mart and just query the data mart. The data mart caches it all, and since it's all in memory, it kind of just reads it directly. So all of these functionalities will be under the hood. What you as a user will see is just an interface that it'll be like a GUI, and it'll be like a wizard. They'll tell you what you want to do. Do you want to query HDFS? Do you want to query other databases? Do you want to use T-SQL, or do you want to use Apache Spark? So it will be all under the hood. You won't get to see any of that. But that's what it's doing. It's all in Kubernetes. So we talked about this. Each pod contains data. So because the scale out, so we need to talk about this because of the fact we are using Kubernetes. We have the ability to scale out compute pools because we are using Kubernetes, because it's an infrastructure that allows that. So it's a very smart decision that they made to really have SQL Server run against Kubernetes. Now, we talked about the fact that you can run your queries against different databases. We talked about data marts, and we talked about the fact that there will be a wizard that'll help you manage all of this. You don't really have to get into the very internals and manage it. It will all be under a wizard. Of course, initially you have to create all of that. So for the database engine, let's change topic. So that's pretty much what we had to talk about as far as big data was concerned. So let's do a quick review. Big data cluster is all about querying your HDF, storing, and not just querying, storing, managing, administering, as well as querying your big data using SQL Server, which has never been done before. And not just your big data, but also other databases. And not only that, have that scalable, not just scalable in terms of storage, but also scalable in terms of compute. So that's what you can expect out of big data clusters. All right, so that was really interesting. Let's change topics now, talking about database engine. Here's a huge list of things that are new in SQL Server 2019, except for the first one. So if you're familiar with SQL Server 2017, you would know that there was this new concept of adaptive query processing created in SQL Server 2017. And now in that adaptive query processing has been enhanced. So what has been enhanced about it? So the below things that you can see are some of the things. So one of the things that the adaptive query processing now has is memory grant feedback. Okay, so we need to explain what that is, right? I mean, how many of us here know what that means? No one. So what is memory grant feedback and what's a batch mode? So batch mode was introduced in SQL Server 2017 as part of adaptive query processing. Batch mode lets the query processor or the query processor and as well as the query optimizer to operate rows in batches and not in just single rows. Previously, in the old versions of SQL Server, the query engine used to read the data line by line. It would used to apply functions and joins and all those kind of things, process your data line by line. Now there's a batch mode kind of situation that it executes the entire batch, a single batch of records altogether, and a second batch of records altogether. It's not an individualistic thing. So, so there was a reason for that, because there's a concept of memory grants. So whenever you run a query, that query requests for some memory. So it's called a memory grant, meaning I'm granting you the memory to execute your query. And a lot of times, when you used to run a query that's, say, very extensively long, and that query would naturally ask for a lot of memory. Sometimes, even if the query was not that big, it would still ask for a lot of memory, which was problematic. It was problematic because the query is, let's say, requiring just 10 megabytes of, needs 10 megabytes of memory, but it's requiring, let's say, 100 gigabytes of memory. That's very problematic because that's a lot of memory being wasted. Even if you don't use that 100, your query is still using just 10, it will still occupy the space of the remaining space of 90. So this is what was happening when we were doing row-based kind of situation. So now in SQL Server 2019, when you run a query again for the second time, so the first time you run it, it will do some calculations and try to adjust the memory grant to the best possible grant, the best possible match, because you don't want to lower estimate as well. Because if your query is, let's say, asking for 50 megabytes of memory, but in reality, the query actually needs 100 megabytes of memory, then also you get into trouble. You get into trouble because you don't have enough memory, so you have to read from the disk. And we all know reading from the disk is not good. It's very slow. So giving less memory is a problem. Giving more memory is a problem. So every time you would run a new query, or even the same query, so every time you would run the same query, the SQL Server would every time give extra memory. So if I run the query the first time, it gave it 100 megabytes. The next time it would still give it 100 megabytes, and the next time it would still, and would always give it 100 megabytes. It would never learn its lesson. Now in SQL 2019, it does learn its lesson because it's adaptive. So it's adaptive query processing. So what happens is if you run a query and let's say it doesn't use up all the space that it was granted, the next time you run the same query, it's going to reduce the memory grant so that space is not occupied by that query. All right, so that's what they mean by memory grant. memory grant feedback. So you can give feedback that, hey, this query didn't really use all the memory that you give it. So next time, please don't give it more. So that's really interesting. And this basically means that your database engine is basically faster now because of that. Not only that, there are other things because of which it's faster. We'll talk about it. So that's one checked off the list. The other one here is table variable deferred compilation. For this, we have a demonstration. So basically what used to happen is whenever you have multi-statement table valued functions, or you have a table variable, you should check out the execution plan for those things. For table variables and whenever you join a table a table variable or a multi-statement table valued function to a simple normal table, you should check out the execution plan and see what it does. What you'll notice is that the estimate execution plan will tell you that there's only one row in the table variable, which is not true because the table variable can have many rows depending on how that table variable is, what you inserted into that table variable later on. So this was a problem because I guess I'll just show this to you. This was a problem because the execution plan that was created was created assuming that there's only one row in the table variable. And creating an execution plan like that is not good because I guess I'll just show this to you. You'll see what this does. So we're going to use the lab environment to see why it's not good to use an incorrect execution plan. All right, so first, I'm going to go ahead and use my SQL Server 2019. And that's just going to open SQL Server Management Studio, SSMS. I guess that's the query that I want to run. So we'll just open that. So there's this new intelligent query processing concept. And intelligent query processing has all of these things in it that I showed you on the slide. All these things that you see here, the first 4 things, all these things come with intelligent query processing. They're all combined into a single product called intelligent query processing. To use intelligent query processing, you have to be in a compatibility level of 150. That's the compatibility level for SQL Server 2019. If your database is not in that compatibility level, then you cannot use these features. So let's actually go ahead and test that. Yeah. So I'm going to go ahead and connect to my SQL Server 2019, and let's see, how do I know this is SQL Server 2019? I mean, is there a way that I can tell? Yeah, I can tell. There are many ways. So first, let me actually just open my files and go to here. Yeah. Just a second. Wow. Yeah. So you can see this is SQL Server 20 version 15. It says here. As you can see, as I hover my mouse over that, it says SQL 2 instance. It's a SQL 2 instance, yeah. So this is the SQL 2 instance. That's the name of the instance. And it says version 15, which is the SQL Server 2019 version. And it says CPT 2.4. That's what I said that we will be working with. All right, so here's the demonstration that we're going through. First of all, we have the T-SQL database. Okay, so we are working with that. And the compatibility level, we're going to set it to, first of all, let's see what it is right now. So the compatibility level for SQL 2 right now is none. What Why doesn't it say here? Interesting. That's really interesting. Let me actually execute. No, oh, I see. I'm in T-SQL. So I have to go to the T-SQL database. Actually, I don't. But oh well, let's just execute this. So I'm going to change the compatibility level for my database to 130. So what does this do? It makes my SQL database be as if it was SQL Server 2016. So now it's acting as if this database is of a SQL 2016 database. Okay, now what I'm going to do, so let's just assume we're working in SQL Server 2016 because I've changed the compatibility to SQL 2016. Now in this database, I'm going to create this variable. It's a table variable. Now it doesn't have to be a table variable. It can be a multi-statement table valued function. But for the sake of the example, we're just going to use a table variable. Okay, because multi-statement table valued functions also have a table variable. So in here, what we're going to do is that we're going to define a table variable, and we're going to define some of its columns. After defining some of its columns, we're going to insert some data into it from another table. And at the end of the day, what we're trying to do here is, let me just clean this up a bit. Just clean this up. Yeah. So after filling in the new table variable with data, I'm just trying to join it. I'm going to join it with my sales.customers table. Okay, so that's what we're doing. It's just a simple join. And of course, we're also doing some aggregation. So we're joining these two tables and doing an aggregation using a group by clause. So this, once again, is a table variable, not a simple table, not a table expression. This is not a view, not a table valued function. This is a multi-statement table valued function, not an inline table valued function, which is why we can do joins against. So we're going to execute that, and we might need to, let me just check for one thing before we execute this demonstration to see if the database actually has these tables. So sales.customer, yeah, it does. All right, so no problem. So it does have that. Yeah, it does. All right, so let's run this. What we want to see here is not the answer. We want to see the execution plan, because what we're talking about here is the database engine. So I'm going to say display estimated execution plan. Okay, so let's analyze what the execution plan is trying to do. Or even if I say include the actual execution plan, it'll be the same plan. But let's see what it's trying to do here. So right off the bat, you can see that it's doing two table scans, a hash match, and it's doing a nested loop. Right? So nested loop, you know, is one of the slowest ways of doing joins. Right? This is the slowest way of doing joins. The easiest way, but the slowest way when it comes to large data. When we have large data, this is not an optimal solution. And it's doing a table scan, sure, but notice, I guess I'll have to, yeah, notice in table variable, how many rows is it estimating? It's estimating the total rows in the table variable will be 1. And here it's estimating that the total rows in this table are 800 and how much? 8,281, which is correct. So this is correct. That's how many records are in this table. But in this table, the table variable that I created, it's saying that it only has 1 row. But that's not true, because I'm inserting some data into that. I'm inserting data through the sales orders table. Now let's execute this and see what the actual execution plan looks like. And no doubt it's the same. Okay, so it's the same, nothing happened. Now let's switch over to the SQL 2019. Changing the database to SQL 2019 now. And notice the execution plan will be completely different. And since the execution plan is different, the query will run faster. So naturally, all your queries that have been running slower, that involve these multi-statement table value functions or table variables will naturally run faster now. And let's analyze this. Let's just execute this. So I've executed this. Now let's look at what it's trying to do here. So it's a complete different plan. Notice how I just changed the compatibility levels. The entire query plan, the execution plan has completely changed. Interesting. Now it's estimating that this table has 830 rows, which is the correct number. And this is also the correct number. Now that it knows how many rows these two tables has, it can make a better judgment as to which operators it should use to execute this query. Previously, it didn't know how many records this table variable had. So the operators that it was using, the nested loop that it was using, was not the optimal one for this table. Now the operations it's using is a merge join, which is perfectly fine for this query. If you do a nested loop, it will be slower for this query. But if you do a merge join, it will be way faster. It's also doing some sorting, also doing a hash match, and stuff. At the end of the day, you will notice that this query actually ran faster in SQL 2019, and merge joins are always faster than nested loop joins. So that's really interesting. How is it work? Why is it doing that? Because of the table deferred compilation. What does that mean? Well, it defers the compilation of the table variable until it's time for execution. So basically, it doesn't compile the table variable right until the execution. Previously, when you execute the code, it will first compile your code and then execute your code. Now, it will compile your code, but it will not compile your table variables. It will compile them right at the execution time so that it knows how many records there are, and then compile the code and then run the query. So that's why it's called table variable deferred compilation. So as you can see, there are huge changes to the database engine. That's just not it. That's just one thing out of so many. So we talked about the memory grant, that your queries will, if you rerun your queries, they will take up less space in memory and hence enhance the memory aspect of your database. We talked about table deferred compilations. You saw what that was. So now you no longer need to fear multi-statement table valued functions because no one used to prefer those. They always used to run slower. And what we used to do was we used to convert those multi-statement table valued functions into inline table valued functions because inline table valued functions used to give us better performance. Now you don't need to do that. There's also something called the approximate query processing. And that's basically in the introduction of a new aggregate function. And the new aggregate function, usually when we had to do, let's say, an aggregate across billions of rows, when we have so many rows, we don't really want the exact number, right? So there are 1 billion rows. Do you really want to be very precise about the number, the counting of, let's say, a column or counting something? It's okay if you're off by 10, 20, 100 rows, right? So now the query processor, actually you have this function called approx count distinct. So what that will do, this is only useful for records where you have million, billion records, where the accuracy of the aggregate function is not as important. Rather, the performance of the aggregate function is important. So the performance of an aggregate function on million and billion rows is going to be horrible because, well, it won't be horrible. It's just going to be very long. But now you have this function that's much more faster than the typical count distinct function because it only does an approximate count. And that's okay because we want better performance than having the right number, because in the million billion range, it's okay if you're off count. So these, like I said, all these things are part of the intelligent query processing, and you need SQL Server 2019 to have them. Now there's also scalar UDF inlining. This has changed a lot of things for SQL Server. So previously, user-defined scalar functions were the nightmare for performance. Whenever it came to performance, scalar UDFs were the nightmare. Every time you use your scalar UDFs in your select statements, your query would face a huge impact in performance because of the fact that your scalar UDFs are actually compiled separately. They're not part of the select statement. The select statement has a separate execution, that has a separate execution, and every time that function is running in the select statement, it has that separate kind of situation. So now you can inline your scalar UDF, meaning when you're writing your select statement, you can just create your, well, it won't be created. Your function, whatever you're trying to do, can be done inline within the select statement or within whatever you're trying to do. So select, let's say a column, and in here you're trying to do something. So you obviously don't have to say create function anymore. I haven't seen the right syntax, but basically what you do is that you define whatever functionality you're trying to create here. It can have whatever functionality you're trying to create. So previously, let's say if it's get numbers, it was a function, a scalar defined function that I created that you give an argument of 2, and it will do something and output a scalar value of, let's say, 5, 6, 7, 2010, whatever. That was what was the case before, and the performance of this function would be horrible. It would slow down my select statement by a lot. Now you don't need to do that. Now you can just inline your function, whatever that function is. You don't need to previously define that function. So this greatly increases performance of your functions. Of course, this isn't for built-in functions. Your built-in functions are good. It's just for your user-defined functions that you create. Those were the ones that were causing the problems. So there's also lightweight query profiling. Lightweight query profiling is very similar to live query statistics, if you're familiar with that. Live query statistics is the ability to look at an execution plan as it is running. So whenever a user executes a plan, they used to have the ability to look at their execution plan as well while it's being executed. So I guess let me actually try doing that for you. So this was something introduced back in SQL 2016. This isn't new. So this icon here, if you click that and run it, you can see, I guess the query didn't even take a second, but what would happen is that this diagram that you see, you would be able to see the rows flowing here, here, here. It would all be happening live. The execution plan would show you at what step it is at, that it's at this step, the rows are being transferred from here to here, it's at this step. So that's what live query statistics was. It was helpful if you wanted to really diagnose something from the core level and from the execution level, but I honestly didn't find a lot of use for that. Now in SQL 2019, you have lightweight query profiling. So what I just showed you, the live query statistics, was something that an individual can do for their own query. Lightweight query profiling is something that a DBA can do against any session. It's the same thing, but it's something that you can do against any session. So you go to the activity monitor, you go to any process, and you can profile that. You can look at what the execution plan is, what the records it's retrieving. you can profile that entire query. You can monitor and profile that entire query. And this is weird. It's not showing me. Oh yeah, there it is. So you can say show live execution plan. This was there before, but now it's something that anyone can do for any that admins can do for anyone. So you see the actual plan flowing. So really cool stuff. Can be used for diagnosis. Persistent memory support and enhancements. So this is also something cool. There's a hardware, usually a chip, that goes into your computer called persistent memory storage. And what that is basically, it's a storage, just like a drive. It's storage, it's not memory. It's storage, but it acts as if it's memory. It's as fast as memory. It's storage, but storage that is as fast as memory. Of course, it's very expensive because think about it's like an SSD, but SSDs are huge. This is just a small chip, giving you the ability to store a lot of things and also have a lot of speed against those things. So when SQL Server didn't really have very good support for such hardware, and the entire market and the business was trending towards these kinds of hardware. So now SQL Server 2019 supports that hardware so that you can store your data on these devices, these persistent memory devices, and your SQL Server will take advantage of the memory aspect, of the fast aspect of that architecture. So previously, SQL Server could get connected and store data on a prem device, on a persistent memory device, but it wasn't using the memory aspect of it. It wasn't fast. So you were investing so much money, but you weren't getting any performance. Now you do get the performance, and you also basically you have the integration of those devices. So you can now store them in those devices and have those performance enhancements as well. Finally, they also have the UTF-8 support. So UTF-8 are character data types. So there are two data types that we are usually familiar with. There's ASCII, that stores alphabets from A to Z and A to Z, and special characters and numbers. So that's what is represented in ASCII. It usually used to take only 1 byte to store each ASCII character. And then there was Unicode. And Unicode can store English and other languages and special characters and smiley faces and everything. So Unicode was kind of like the bigger one that used to represent a lot of many things, whereas ASCII was American Standard of Character Indexing, something like that. And it only used to have American language. And that was the case back in the days. But nowadays, since we have a lot of, since the systems are being used in multiple, are being used globally, we had to support Unicode language, the Unicode system. So if you're storing data in ASCII, you only had to use 1 byte to store each character. Now you're storing data, so not now, in SQL 20, I don't know, 16 or way before, you could store data in Unicode, but the problem with that was it would take twice the space to store that. So even a single alphabet would take twice the space to store. And it's okay. Space is not something that we are concerned about, right? I mean, we can just buy more space. Space is not that expensive. But space is not it. Unicodes tend to be slower than ASCII because you have to read more and write into memory and write and read more from memory as well. So it's not just storage, but also memory. So Unicodes were slower and they were taking more space. So we had to come up with the integration of UTF-8. It's a compressed version of Unicode. It still represents all the languages, but it's a more compressed form and is now the default for SQL Server 2019. So that every time you type in, let's say, declare add car, and you create it as a car and you give it a value A, that A is being stored as a UTF-8. That's the default for SQL Server now. Previously, it was ASCII. Now it's UTF-8. That's a huge change for SQL Server. For the longest time, it was always ASCII. And if you wanted to store Unicode, you would have to have an N before the A. That N would represent that this character is a Unicode character. But if you wanted to store simple ASCII characters, you would just type it like that. And now, if you type it like that, it's going to store UTF-8 character, which is better. So that's the support that it has. We also have the machine learning in R and Python, so and even Java. So if you can write your machine learning code in R or Python or Java. Well, Java is kind of maybe. I'll tell you more about that. So R or Python, and then you can have that machine learning run against many different environments, such as your big data clusters or your relational model or wherever you can fit that in your applications. So that's really interesting because these two languages are very well known for their use and analysis of data, of statistical data or predictive analysis or stuff like that. Right, so next we also have, so you have that ML integration and you can scale that out as well using big data clusters. Now we have security. So we're almost there. Security, what's new in security? The always encrypted with secure enclaves. So what's all that about? If you don't know, always encrypted was introduced in SQL Server 2016. And it was a very good encryption algorithm that used to encrypt your data at rest as well as when it was in flight. So it was always encrypted. That's why it was called always encrypted, because it was always encrypted. And it was a problem because always encrypted would not allow you to do some fast query processing, because of the fact that there used to be some encryption, decryption happening. It wouldn't support fast query processing. So now you have this new concept of secure enclaves. That's actually a hardware level feature that some hardwares have, such as Intel and other hardwares. And what secure enclaves basically does is that now all the encryption and decryption is actually happening right at the CPU level, not anywhere outside of it. So now you can decrypt it and quickly do your query processing. And as it gets out of the CPU, you can it gets again encrypted. So basically it all happens. There's a better hardware, and SQL Server 2019 supports it. As far as our administration and all that is concerned, nothing new, nothing changes. It's just that it's a new feature, and what they're trying to tell us by the SQL Server 2019 release is that now it's always encrypted is going to be much more faster, and much more things are supported with it. There's also classification. You can finally do data classification and use that classification to do auditing of data. So if this is of your interest, if data classification is of your interest, because it can help a lot with management of the data. So you can classify that this data is for this purpose, this data is for that purpose, this data is for that purpose. You can have this all classification tree, and you can use these classifications, data classifications, and have them kind of do auditing as well. So I want to audit this classification of data or that classification of data. So it's kind of like a security and also auditing tool for us. So that's something new, data classification. Static data masking, that's something new. So we all know data dynamic masking, right? That was introduced in SQL Server 2016. So dynamic data masking was basically just obscuring your data. And it wasn't really a security kind of thing. It was just a thing where people who are kind of overseeing your computer screen would not be able to read the data because the data was just obscure. Just like how when you type passwords, all the passwords are replaced with the stars. So that was what dynamic data masking was. Static data masking is different, because dynamic data masking didn't mean that people cannot access the data. People could still get to the data through administrative methods or other methods. Uh, Static data masking is much more secure. It's actually masking the data on the storage level. Dynamic data masking was masking your data on the display level, on the level where you actually get the results over there. But static data masking is masking your data on the storage level, that you're storing masked data. You're not storing simple data, you're storing masked data. And you would need very special permissions to unmask that. And you would unmask that for everyone, and you would mask that for everyone. So it was like a all or nothing kind of situation. So it's much more secure than dynamic data masking. Huge changes in availability groups. First of all, finally, we have 5 synchronous copies of our replicas. I have 5 synchronous replicas. So that's interesting. So previously we had 1 primary and how many secondaries? I think it was 3 secondaries. Now you can have 1 primary and 5 secondary synchronous copies. Or maybe it was 1 primary and 4 synchronous copies, something like that. But the number has increased. That's the point. And that's a big news, right? Now you can support more read synchronous copies. Obviously, the write copy is still 1. The primary replica, the read-write replica is still just 1. I wish they could make that 2, because that would just change everything. But it's still 1. You still can only have 1 read-write replica, which will be your primary replica. The rest of the replicas will be read-only. The one thing that's new here is that now you have more replicas. Big thing. Kubernetes, you can now have availability groups on your Kubernetes environment. So you can have Kubernetes hosting your instances, your replicas, your primaries, as well as your secondaries, your entire availability groups system in Kubernetes. And that's really interesting, because Kubernetes has something called as an operator. And use an operator that kind of sets up an environment for you. So Microsoft created their own operator for Kubernetes, a Kubernetes operator. So you can use these Kubernetes operator to quickly create an AG environment. It really doesn't take a lot of time, just few clicks here and there, and you have an activated availability groups situation happening. So you no longer have to do extensive thinking and programming and stuff to have this enabled. So that's really interesting. And since it's in Kubernetes, how is the failover going to happen? And how are my clients accessing the Kubernetes? And how is all that happening? So what's happening here is basically you have, let's say this is your Kubernetes environment. Inside these environments, like always, you have a storage pool. And in the storage pool, you have your replicas. And each replica has a SQL server. Let's say this is your SQL server. And let's say this is your primary replica. Your primary replica can be connected to a load balancer. A load balancer is provided by Kubernetes, so you don't have to do much. And your clients can use the load balancer. Basically, they write their queries against that load balancer. The load balancer will send the query to the primary replica. Okay, so what happens in case of a failure? And by the way, the rest of the replicas can be synchronous or asynchronous, doesn't matter. Now you can have another load balancer, right? That is also connected to a client, but this load balancer is only doing read transactions against your synchronous copies, against your secondary synchronous copies. So you have 2 load balancers. One is querying the primary. The other is querying the synchronous read-write. Now there's this new concept of agent, the availability group agent. It's a new piece of software that comes along with availability groups in Kubernetes, which basically checks the health of every system, of every SQL server in the Kubernetes environment. So it basically checks if all of them are online, and it also decides whether or not you should do a rollback failover. So in case of a disaster, let's say the primary, something happens to the primary and it's down. So the agent, the active availability groups agent, it will decide that you should cut this connection from the primary, reroute the load balancer to this, and make this the primary. And whenever this one comes back online, the agent, what that will do is that it'll take this off, the secondary off of this primary replica against the new primary replica, and reroute it to this one and make this one the secondary. And then at the end of the day, after the disaster is over, you're again fully functional. You have a fully functional availability groups without even doing anything. Previously, what you would have to do, you would have to do the last part yourself. You would have to read out the read to the newly available or the failure the failed replica. You'd have to read out it to the failed replica once it's online. It wasn't an automatic process. You'd have to do that manually. And if you didn't do that, it would bother the primary replica, because a primary replica would have two load balancers connecting to it, and that would make it slow. So you'd have to manually do all of that. Now you don't have to do that. AG agent does it itself. All you have to do is just sit and watch it all happen. It's not as simple as I make it sound like, but it's really much more better. And finally, SQL Server has system tables in their Active Directory groups. You can finally roll over or fail over system databases from one replica to the other, so that in case of failure, your data files, your system database, your user databases are not the only ones that are kind of replicated across all the replicas. Your system databases are also replicated across, so that you don't have to recreate the logins, the users, the credentials, the job agents, and all the things that you're doing in your system databases, such as model, MSDB, master, TempDB, whatever. So all of those system databases, anything that you were doing in there, you'd have to do it all again, unless you had some backup. So now you don't no longer have to worry about that, because system databases are also replicated across all the replicas. I don't know why this wasn't the case before. I feel like this should have been there ever since AG was a thing back in SQL 2016. But they realized that this was a huge thing that they need to do, and they did it, and everyone was very happy about that. We also have something that's not related to availability groups, online resumable indexings. So now you can create your indexes online. You can rebuild them online. You can reorganize them online. What that means is that you don't have to disable the index to recreate it. It doesn't bring the table down. It doesn't stop anyone's transaction, stuff like that. So it doesn't bother the normal systems. It's all online, and you don't have to bring the index or the table offline. So that's really good. That's good for availability of the table as well as the index. You also have the SQL graph. That's a thing that they made for SQL developers. So sometimes you have systems that are storing data that require kind of graph situation, that you have nodes and you have edges. So the data that you're trying to store is kind of something like a map or kind of something like that, right? That it's best fit in some situation like that. So you can use SQL Graph to store things like those, things that are kind of like a map or kind of like Yeah, kind of like a map or our maps. Because now you can have tables act as if they're edges or nodes and store data in them. So edges are just used to connect nodes, and nodes contain data. So this was in SQL Graph, it's way easier to handle that. Without the SQL graph, implementing something like this would be hectic. So SQL Graph is not something new. It was introduced in SQL 2017. There are some few features that are new in SQL Server 2019, such as having more capability over your edges and stuff like that. SQL on Linux. Yeah, so like I said, this is not something new. It was introduced in SQL 2017. But when it was introduced, since they kind of rushed it because they were kind of falling behind market, all their competitors had SQL running on Linux, and their SQL Server was not running on Linux. They had to kind of fast pace that, which is why they left out some features from SQL Linux. So those features, what are they? Let me just, yeah. So those features were basically replication distribution. So that's a huge thing, and that wasn't there before. Now it's here. ML, so machine learning wasn't there before, and distributed transactions was not there before. Replication, distributed transactions, and machine learning, these things were not there in SQL Linux. These were recent things, right? These were things that were introduced recently. That's why they couldn't make it to the SQL Linux, although they should have, but they didn't make it to the SQL 2017 Linux, but now are part of the SQL 2019 Linux. The thing about this, all this kind of Linux situation is how amazing how they made it is that the underlying code, the database engine, everything is the same. There's nothing different about SQL Server running on Linux versus SQL Server running on Windows. Because you would kind of question, right? So wait, if I'm running on Windows, will that be different? Will that be a different environment than a SQL Linux? Because you would kind of think about, okay, it might be implemented differently. It might have some features that Windows SQL Server doesn't have, that Linux SQL Server does have, and kind of like that situation. But it's not. It's completely the same thing. The underlying code is exactly the same. In fact, when you go down to the assembly level, when the Intel chip is interacting with the code, it's exactly the same as SQL Server that we know of. So you don't need to worry about the fact that, oh, I don't know if it's the same thing or not. It's the same thing. It's the same thing as a Windows SQL Server. So that's really great of Microsoft to do that. Because a lot of times when we have these kind of platform enhancements, platform inclusiveness, right? So when you try to include more and more platforms, you kind of deter from your original code, and you kind of start questioning that whether or not your code is actually going to run faster on Linux, or is it going to run faster on Windows, because it's not the same code. But you don't need to worry about it. It's the same code. Finally, we also have the Azure Data Studio. Now, this is kind of interesting. I can show this to you as a demonstration. Let's see here. Yeah. So this is the Azure Data Studio. It's a new tool. It's kind of like a SQL Operations. If you know about SQL Operations Studio and SQL Server Management Studio, it's kind of like a mashup of those two. And I don't know why they called it Azure. All right, so don't ask me. It has nothing to do with Azure Portal. If you're guessing, it's just another SQL Server Management Studio, honestly. It has some more capabilities that SSMS doesn't have, actually a lot more capabilities that SSMS doesn't have. So you can connect to, just like SQL Server Management Studio, you can connect to your data. Let's say I'm going to connect to my SQL 2 data. Come on. They're still in the making of this Azure Data Studio, so it still might be a bit clunky. Let's see. Come on. Let me just connect to it directly as a new connection. So this is the connection manager. I guess just the connection. When SQL Server when SSMS pops up, you see this in front of you, and you have to type the server name. Now for the server name, I don't remember the name. That's the name. Can I just click that? Yeah. So you can just click that, the recent connections. This is amazing, right? So you can just click all the, you can see all the recent connections you have. Just click that one and click connect. See how easy it is to use this. Uh, so much better than SQL Server Management Studio. But I personally don't like the UI. I just like the features that it has. I believe they could do better in the UI part. UI for this is so much better, but oh well. I don't know why this is not connecting, but basically there are a lot of things that you can do in here. So Azure, no idea. I guess this is not working right now, no idea. So basically what it is a tool that you can do administration on, you can do development on. It's a kind of like an all-rounder tool. This is the preferred tool to get connected to your big data using the new big data cluster and get connected to your relational data. So what you will see is something really interesting. You'll see your normal tables, your relational normal customer table, sales table, and in the same interface, in the same list, you will also see your big data. And that's so interesting because this has never happened before in the SQL world, where you are looking at your relational data and your non-relational data all in just a single list. You can click any of these and query any of these at any time using T-SQL or Spark. I guess not your relational data with Spark, but your unrelational data with Spark. And you can kind of join them together as well. So this is the most interesting part. You can join non-relational and relational data. Not that it would make a lot of sense, but you can do that. And Azure Studio is the way to go about using this new technology because it has the capability to not only connect to HDFS sources, but also relational database engines as well. That SQL Server Management Studio does not have. So you can view your relational and non-relational data all in one window. So that kind of wraps up everything. So let's really go through a quick summary of all the things that we got to learn, and then we will do a quick Q&A session. You can start typing your questions in. So what did we learn? Big data cluster, a huge tool, complete game changer, does data virtualization through Polybase, through the use of Polybase external tables. Since the big data cluster is on Kubernetes, it's extremely scalable. The storage is extremely scalable, as so is the compute. So both the compute and the storage is scalable. So using Kubernetes and Polybase, you can query your HDFS, Hadoop, non-structured data. You can query your Oracle data, Teradata. You can query data marts. You can query Internet of Things. All of that in one package using T-SQL, using Spark. So that's amazing. That's big data clusters. That's the reason why we don't have to do ETL process. We don't have to go to these different sources, go to Hadoop, go to Oracle, go to Teradata, do ETL processes and get data into a single location. You don't have to do that. It's all virtual now. There's availability groups that we went through that now you can host that on Kubernetes as well. And it has this agent that does a very good job at managing the availability groups. You can also have system databases fail over to the other replicas. You now have SQL Linux that was there before, but now it has new features that we talked about. Database Engine has a lot new things. There's intelligence query processing. There's UTF-8 character processing support, and then there is also inline UDFs, scalar UDFs, and what was there? So there was one more thing. So we understood all of these things, right? Any questions about any of the things that we talked about so far? So let's just open the floor for discussions. You can type your questions in the chat window.
Yeah, so you've got the chat window, you've got the Q&A section as well. And while I have you guys, let me share the link to a portal with you guys, all panelists and attendees. There we go. So if you have any questions later on, for example, when you're going through the recorded version, or you have a question later on, you can just go to expertconnect.quickstart.com and post a question in the relevant section. So we have a question from Brandon. Does SQL Server 2019 tie in closely with Cosmos DB?
Tying closely with Cosmos DB, do you mean does it have the ability to get data from it and query it, and how fast is it against Cosmos DB? I believe that's what you mean. Or do you mean in comparison to SQL Server 2017, is it kind of up to that level? So if you mean the first thing, then yes, you can query your Cosmos DB through SQL Server 2019 through the big data cluster kind of situation. And you can use simple T-SQL to do that. Or your Spark. If you know how to use Spark, you can also use Spark to do that. It does tie in closely in that sense.
And how does it handle Cosmos DB storage limitations?
Good question. So the technicalities exactly are not still revealed by Microsoft as to how they are handling all these things. The exact documentations of all of these are yet to be released. We would only know uh, how this is actually handled when we actually have the SQL Server 2019. So far, we know that there are these possibilities, except that we just don't know yet how SQL Server or Microsoft is actually implementing that in the code and how they're actually handling those storage limitations that are in Cosmos DB.
So we have another question by John. How would it operate with Progress DB as an external data source?
I am not very familiar with Progress DB database, so I won't be able to give you a good answer. Um, but I'm sure there should be some integration of that. As far as I know, I didn't see any mention of Progress DB in the notes, in the release notes, and anywhere online. So I'm not exactly sure about that.
So we have a comment by Michael. I would have thought that Linux could do a much more efficient job of reading and writing data than Windows with all the unnecessary overhead it adds. Since the code is exactly the same, would we still get those types of OS advantages going to SQL on Linux?
Yes, this is what I was thinking about as well. Good question, Michael. So this is exactly one of the questions I had in my mind as well. So wait, if we are switching to Linux, doesn't that mean things will naturally just run faster because it's so much better of a operating system for applications than Windows. And I'm expecting that is true. I'm expecting that Linux will handle uh, SQL much better than the code is the same, right? The implementation is the same, but how Linux will respond to that code and how Windows will respond to that code is going to be different. And I'm expecting that Linux might just be faster than Windows. That's just my expectation. I can't say for sure. So will SQL 2019 work with SharePoint 2010 and 2013? A good question. So you're talking about compatibility of SQL Server 2019 with SharePoint. Uh, hmm, I think it goes as far as SQL SharePoint. Yeah, I think it has that. I think it does support 2010 and 2013, both of them. Yeah, it does support them.
All right, so we'll I believe that's all the questions that we have. Thank you, guys. Thank you, Abdullah, for a very detailed session on SQL Server. And what's next? I think we can do one with you next week as well. Next month. Week would be a bit too short notice. Um, and thank you everyone for joining. I know some of you have signed up for a session later on today, and that's exactly the kind of lifelong learners we want to engage with here at QuickStart. So see you guys in 1.5 hours for the Cisco session. Thank you, Abdullah. Thank you very much.
See you all. Bye.
Okay.